Hi everyone, welcome to my channel, and in this video series of preparing for an job interview specifically for the job role of electronics embedded hardware design engineer. The electronics subject itself, the name itself came from the term electrons, and these electrons are nothing but electric charge particles which are present in an atom, and the electric charge carried by these electrons, the value is given by 1.6023 into 10 to power minus 19 coulombs. The unit of electric charge is coulombs, hence the charge carried by an electron is given by 1.6023 into 10 to power minus 19 coulombs. When these electrons flow in a material, they form current. This flow of electrons in a material is nothing but electric current. Now the material are further classified into three types. The materials or substances are further classified in electronics terminology, are further classified into electronic or electrical insulators, electric conductors, electric semiconductors. So the insulators which does not allow the flow of electrons to pass through it are known as insulators, and the conductors are the materials or the substances which allows the flow of electric charge or electrons or electric current to pass through it are known as conductors. And semiconductors are the materials whose properties are between insulators and conductors. That means they can act as an insulator and they can also act as a conductor based upon the external field or external conditions applied on those particular semiconductors. So they can act as an insulator based on certain temperature or voltage or various other parameters, or based on its field applied on it. Now these insulator conductors and semiconductors further are used to make electric devices. Correct. These electric devices are made of this kind of materials, and they can be further divided in the various categories such as resistors, capacitors, inductors. So these are the electronic or electrical devices constructed using the materials. Now let us understand what is resistor. Resistor is a material which has the property of opposing the flow of current or opposing the flow of electrons to pass through it. So if the resistance of a resistor is more, that means it does not allow the electrons to pass through it, or it does not allow electric current to pass through it more easily. If the resistance of a resistor is less, that means it allows the electric current to pass through it more easily. So it is represented using this symbol, and its value has some units. So resistor has a value in terms of resistance, and its unit is ohms, and symbol is this. Now this resistor in electronics, when you do a design, are of various packages. Packages is the construction. For example, these resistors can be obtained in leaded format. That means the resistor can have two leads and can be known as through hole or leaded resistor. So that component can be called as through hole or resistor, through hole or leaded component, or an SMD. SMD means surface mounted device. So that particular resistor can be mounted on a PCB and soldered without going through the holes of that PCB. So you don't need the holes made on the PCB board or printed circuit board to mount their resistors if it is a assembly package. So the next category of electric devices mostly used in electronics design are capacitors. Capacitors are the electronic device or electric device which stores the energy in the form of electric charge, and its construction is usually made by two metallic plates separated at a distance or separated using an insulator or a dielectric material which does not allow the current or electric charge to pass between one plate to another plate directly, and its construction is something like it's a metallic plate separated at a distance, and you have an insulating material between these two metallic plates. That means the electric charge or electric current does not, or electrons will not transfer itself from one plate to another plate directly, as the insulator is between, which does not allow the electric or the electrons to pass through the material. And the capacitor's value can be defined using the term capacitance. And its unit is farads. So normally in the market or in the design we use the capacitor values such as microfarads, picofarad, nanofarad, and for resistance we use ohms such as ohms, kilo ohms, mega ohms. Now if we talk about inductors, inductor is also another electric device which stores the electric energy in the form of electric field, and the construction of the inductors is in a way that when an electric wire, an electric conductor, an insulator wire is wounded on a metallic rod, then its property is such that it stores the energy in the form of electric field whenever a current passing through that electric insulated wire. So we have a metallic rod represented like this, and we have a insulated wire. So that means a copper wire which has an insulation across it. That means if you touch that wire, the electric current will not pass through it. So that insulated wire is wound like this on this metallic rod, and this wound is known as coil, electric coil. So whenever electric current passes through it, it stores energy in the form of electric field, and its unit is given as Henry. And the property of this inductor the value can be defined as inductance. And the usual values used in our electronics design will be millihenry, microhenry, and so on. Now let us discuss these electrical properties of these electrical devices one by one. So let us consider the resistors. So to explain the electrical properties of these resistors, let us consider an example of voltage divider circuit. This voltage divider circuit is most often used in most of the design, in all the designs of an electronics hardware. So let us consider two resistor values which are connected in series. This is R1, this is R2. Let us name them as R1 and R2. And we have an input voltage of E in, and we are measuring an output voltage across R1. And consider this as a system. This is the input terminals and this is the output terminal, and we have a input current flowing through this, maybe IN. So this input current is flowing throughout the system and going back to the source. This is the positive side and this is the negative side. Okay. Now, if you see, according to Ohm's law, the input voltage is equal to the product of total input current into sum of the resistance. Hence, we can write that as EN is equal to input current into sum of the resistance, that is R1 plus R2, and as per the Ohm's law, we can also say that this output voltage is equal to, which is measured across this resistor value. That's why this voltage is equal to the current flowing through this resistor and multiplied by this resistance value. Hence, which can be given as E out is equal to IN into R1. Since this same IN is flowing through this resistor as well, hence this E out is equal to IN into R1. Now, if you take this equation, then this, if you move this R1 plus R2, this is equation 1 and this is equation 2, and in this equation 1, if you move the R1 plus R2 to this side, to the left hand side, and divided by En, then En divided by R1 plus R2 is equal to In. Now this becomes equation 3. Now if you substitute this equation 3 in equation 2, then we get E out is equal to E in divided by R1 plus R2 into R1. So this is our final equation, right? So the output voltage is equal to total input voltage multiplied by the resistance across which the output voltage is measured divided by the sum of the resistance. So we can rewrite this equation as output voltage is equal to total input voltage multiplied by the resistance value across which the output voltage is being measured. So since the output voltage is measured across this resistance, then the input voltage multiplied by this resistance value R1 divided by sum of the resistance. So we will be using this formula very frequently in our consecutive videos. And if we move this E in to the left hand side, E out divided by E in is equal to R1 divided by R1 plus R2. and hence this becomes the transfer function of this particular system and also known as gain of the system, which is equal to G. So hope this is clear for the resistors. Now let us discuss the electrical properties of a capacitor. So for a capacitor, as mentioned, that it stores the electric energy in the form of electric charge, and we should understand that this electric property of a capacitor depends upon the impedance when it is when it is kept in a circuit. So for example, when a resistor is kept in the circuit and it provides some resistance property. Similarly, the resistance property of a capacitor or the impedance property of a capacitor is also known as capacitive reactance. Now we will discuss about this capacitive reactance property, which is impedance. Z is equal to 1 by 2 pi Fc, where F is the frequency, C is the capacitance. Now you can see from this equation, Z is the impedance of a capacitor. And F is the frequency of the input signal when provided to the across the capacitor. So as this part is 1 divided by 2 pi Fc, the frequency is inversely proportional to the impedance. That is, impedance is inversely proportional to the frequency. That means if the frequency is increasing, your impedance of the capacitor is decreasing. Since frequency in the denominator side, if the value of this frequency is increasing, so the value of the impedance is reducing. For example, if this is order 1 and this is the frequency is reducing. For example, if the frequency is reducing, then the value of the impedance is increasing, as it is inversely proportional as it is in denominator side. So when the frequencies of the input signal is reduced, the amplitude of the value of the impedance is increased. And this 2 pi F is also known as omega, and this can be rewritten as Z is equal to 1 by omega C. And there is also one important point to remember, that the voltage for in a capacitor lags the current by 90 degrees phase shift. So that is, voltage lags the current in a capacitor by 90 degree phase shift. In my previous videos, we have discussed how that happens. So for example, if in a capacitor there is a voltage and current, the current the voltage lags the current, hence the current signal would be like this. Which lags the voltage lags the current by 90 degrees phase shift. Similarly, let us discuss about the inductor. The inductor, the impedance in an inductor can be defined by an equation known as Z equal to 2 pi FL, where F is the frequency, L is the inductance of that inductor. So this is also known as inductive reactance. And with this equation we can understand that Z is directly proportional to the frequency. That is, if the frequency is more, impedance of that inductor is also more, and if the frequency is less, impedance of the inductor is also less. So if the frequency is less, impedance also reduced. If the frequency is more, increasing, then impedance also increasing. And this can also be written as Z is equal to 2 omega I, where omega is equal to 2 pi. And for the inductor, we should remember that voltage leads the current by 90-degree phase shift. So for in case of capacitor, I have mentioned that voltage lags the current by 90-degree phase shift, but in case of inductor, voltage leads the current by 90 degrees phase shift. Now, with these electrical properties, we can further discuss that using these electrical elements, we can separate the various frequency components in a circuit, using a circuit. For example, we can design a circuit which allows the low frequency signals and attenuates the high frequency signals. Then that particular circuit is known as low pass filter. That means it is filtering out the high frequency components or high frequency signal components of a signal and allowing the low frequency component of a signal. Then in such a case, that particular circuit or a device can be called as low pass filter. And this low pass filter can be constructed using capacitor or inductor. Let us construct this device using a resistor and a capacitor. And similarly, we can also construct a low pass filter using resistance and inductor. So that can be known as RL low pass filter. So we will be discussing this low pass filters, RC and RL low pass filter, in our next video. So hope to see you in my next video.